Question number 4 for our rates in equilibrium practice test number 2 is this one. A chemistry student exposed a system of hydrogen, nitrogen, and ammonia at equilibrium to several changes and recorded the changes in concentration of each species over time. The graph of the results from these experiments is shown below. So here you can see how the concentrations of all this stuff changed over time. There's obviously 1, 2, 3 changes that were made. After which changes is the forward reaction greater than the reverse reaction? So for this to be right, the forward reaction to be greater, my concentration of my reactants should be decreasing. Alrighty, so therefore let's have a look. My reactants here would be my nitrogen and hydrogen. My products would be my ammonia. How do you know that? Well, you kind of don't, but I probably should have put in a nice equation here to find that. So therefore my reactants are here. Anyway, let's move on. After which changes is the forward reaction greater than the reverse reaction? So when are my reactants decreasing? Hydrogen and nitrogen are my reactants, so therefore here I can see that they are starting to decrease. Nitrogen's going down, hydrogen's going down. I'm producing more ammonia. At this point in time, they're also going down, but in this point in time, they're going up. So therefore, the forward reaction is greater than my reverse reaction after T1 and T2. And that is my response to that question, because I can see that my reactants are going down when my forward reaction is greater than my reverse reaction. At time 3, the temperature of the system was increased. Is the reaction between hydrogen and nitrogen endothermic or exothermic? Okay, so what do we know? So if I increase, so guaranteed, Le Chatelier's principle, all right, says an increase in temp favors the endothermic reaction. All right, so let's just write that down because I know that that is true. That's guaranteed to be true because that's law by Le Chatelier's principle. An increase in temperature is going to be partially opposed by favoring the endothermic reaction. Let's look at my graph. My graph. An increase in temp favored, what was favored in my graph? My reactants are going up, so my backwards reaction must have been favored. So backwards reaction. So what does that mean? Therefore, the backwards reaction is endo, therefore my forwards reaction must be exothermic. And we have my response. Okay, so looking down this path, I go to concrete information. I've got a concrete information in terms of Le Chatelier's principle as to what temperature does in this case. I go to my graph and say what happened in this case, concrete information. I then put 2 and 2 together. Endothermic's reaction is favored. That has to be the backwards reaction. Therefore, the forwards reaction must be exothermic. And that gets my answer. Use the graph below to show the number of moles or how the number of moles of Y would have changed over the same time frame. So let's have a look at what's happening here. What were my changes? That's what I need to find out. So initially, what was my change here? My change here was I added, let's just ignore this and let's go with change in nitrogen. Obviously, I've copied and pasted these questions and it's not ideal. But anyway, number of moles of nitrogen. Let's go with that. Okay, so here I added nitrogen. Here, what happened? All 3 concentrations increased. So that means I decreased my volume, or I increased my pressure by decreasing my volume. And here, what happened is I increased temperature. So addition of nitrogen, in terms of concentration, that it will be the same for number of moles. So my number of moles of nitrogen will go up because I added, remember I added nitrogen, okay? That gets partially opposed and it starts to decrease until we get to equilibrium and then we get to time 2. Here I decreased volume, all right? That caused my concentration of nitrogen to shoot up. However, my number of moles, so my number of moles of nitrogen is not changing at this point in time, but my concentration is. What's favored? The backwards reaction, so therefore it's going to start to go down and therefore I reach equilibrium here. And then what happened at time 3, I increased my temperature and the concentrator starts going up. That means my number of moles starts going up again, and then it reaches equilibrium again. So that's going to be the change over time. Key thing is, with this question, it's knowing the difference in concentration and mole when you're changing